Among the three measures of central tendency, mean is the most popular and commonly used and the most important for inferential purposes. However, it is important for us to actually explain how the data scattered or spread from the central values. So the dispersion of data is also known as variation, variability, or disperse. The larger the dispersion, the wider the data set are scattered. In figure 2.2, we can see that we have two different groups, group A and group B. For group A, the data are more widely spread compared to group B. So we look at the tail, the left and the right tail. Meanwhile, for B, it's over here. So based on this graph, group A are more widely spread compared to group B. Group B are tightly clustered. So that means in this case, group A is more dispersed compared to group B. Group B is more consistent. Comparison between these two groups only can be made if the mean are equal. Measure of dispersion for ungrouped data. So we have 4 formula in this chapter. So the first one we have here is for range, interquartile range, quartile deviation, and then on the next slide we have variance or standard deviation. Okay, so for range, the formula here, largest value minus smallest value, or sometimes we take this maximum value minus with the minimum value. So in example 2.39, the following data shows the number of eggs collected from 10 chicken. So find the range for this data set. So the range equals to the largest value, we have 90, minus with the lowest value, in this case we have 46. So the range for this data is 44. Okay, so for interquartile range, under the assumption that you already calculated the value for quartile 3 and quartile 1, interquartile range is just simply you take the value IQR equals to quartile 3, 74.5, minus with quartile 1, 55.75. So you are going to get the answer for interquartile range. The value is 18.75. So the third formula that we have here is quartile deviation. So for quartile deviation, under the assumption that you already calculated value quartile 3 and quartile 1, so the formula for quartile deviation, so 74.5 minus with quartile 1, 55.75, and then you need to divide by 2. So the final answer that we are going to get 9.375. So this is the value for quartile deviation. So next we have standard deviation. So we can see here, this is for standard deviation. And then for the symbol for standard deviation is S. And then we have S square here, referring to the variance of the data. So this is for variance. The symbol for variance is S square. So the difference between standard deviation and S square is, for standard deviation, you need to square root the formula, but then for variance, we don't have the square root. Okay, so the formula will be given during final examination. Let's take a look at example 2.43. So for example 2.43, the data below shows the number of students who enter library for 12 days. Calculate the standard deviation and variance. And then this is the raw data or ungrouped data. So based on the solution, so we are going to use this formula or this one. Okay, so based on that formula, we need to find the summation of x squared and then the summation of x. So first you need to calculate the summation of x. So in order for you to get the summation of x, you only have to total up value of x, so 30, 24, 55 until the last value that we have 45. So the final answer is for summation of x equals to 553. And then based on this formula, we need to find summation of x square. So based on summation of x square, you need to square every value and then you need to total up everything, and you're going to get 28373. And then we only need to replace the value into the formula. So the formula we have here, n referring to the total number of observations. So you need to calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. So 12 minus 1. So we replace n equals to 12. 12 minus 1. And then this is summation of x square. And then this is the value of summation x. This one is for n. And then we just calculate it using calculator. So formula, this one is for variance, no square root. So you are going to get the variance for this data, 262.6288. But then in order for you to calculate the standard deviation, you need to put the square root. So if you just simply put the square root to the variance over here, s square, so you are going to get the final answer. This one is standard deviation. Standard deviation equals to 16.258.